Dear viewer, in embryology today we are going to discuss about cleavage and different patterns of cleavage. What is cleavage? The cell's divisions occur during embryonic development are called cleavage, and the cells that cleavage produces are called blastomere. The first cell division of the zygote produces two daughter cells. These blastomere divide at the same time. If it occurs at the same time, then this pattern is called synchronous. It produces a four-celled embryo. Later, the divisions become asynchronous. Asynchronous means the process is going on not at the same time in the next two type of cells. Now more blastomeres are produced. The embryo does not increase in size during early embryology. Rather, the blastomeres become smaller. Thus, the proportion of DNA to cytoplasm increases. Now, we understood about cleavage, blastomeres, and number of cells which produced after second, fourth, and so on divisions. Now we have cleavage patterns. Different cleavage patterns are present in different organisms. Basically, it can be classified on number one, basis of amount of yolk. Number two, cleavage pattern based on division of egg. And number three, cleavage pattern based on orientation and fate of blastomeres. Number one, as I told you, that cleavage pattern based on amount of yolk. The yolk influences the cleavage patterns. Some eggs have evenly distributed yolk. Cleavage patterns in these cells produce blastomeres with uniform size. Some eggs have unevenly distributed yolk. Their cleavage patterns produce unequal blastomeres, and we knew well that blastomeres are new divided cells. Second, we have cleavage pattern based on division of egg. Thus are two types of cleavages. Number one, holoblastic, and number two, merosplastic. Holoblastic cleavages that completely divide an egg is called holoblastic. So it means divided cell will be divided itself into two equal halves. Merosplastic cleavages that cannot completely divide the embryo due to large quantities of yolk is called meroblastic. These embryos develop around or on top of the yolk. Third category we have cleavage pattern based on orientation and fate of blastomeres. These cleavage patterns are produced due to differences in the orientation of the mitotic spindle during mitosis. It also shows the fate of early blastomeres. The developmental differences show the differences in the evolutionary history of the animal groups. In this case, we have some examples. For example, in case of echinoderm and chordate lineages, in this case, blastomeres are oriented directly over one another. This pattern is present in echinoderms and chordates. Second, we have from annelids and arthropod lineages. In this case, an upper tier of blastomeres is twisted out of line with a lower tier of blastomeres. This pattern is present in the annelids. You know well annelids are segmented worms, and arthropods, these well-known classes, insects and their relatives. After the cleavage patterns, different type of germ layers will be produced or developed. What are germ layers? The layers or blocks of embryonic cells which produce tissues and organs are called the primary germ layers. The development of these layers from a nondescript form in the early embryo to their form in later embryonic adult stages is called differentiation. These are basically three layers. Number 1, ectoderm. Number 2, endoderm. And number 3, we have mesoderm. After the further developmental stages, ectoderm will give to the outer body wall or skin. Second, we have endoderm. It will form the inner lining of the digestive cavity. And in case of mesoderm, it gives rise to tissues between ectoderm and endoderm.